Here's a type of pool and weir, the Ice Harbor. It was designed out west for salmon. And it has a central baffle with two weirs on the sides where the flow passes over. Here you're increasing your flow range now. This is a bigger fishway type. But the maximum head pond swing's only a foot because hydraulically you really want to stick within a tight window. So here's one on the Merrimack River. It's a half ice harbor. And you notice right away how turbulent that is. And it's because to get these fishways to be properly submerged and in that streaming regime, it's not very easy. This one here, design flow, you're seeing 15 CFS passing through there. It has a drop of 1 foot. This is another fishway that was unfortunately designed for salmon, and the salmon program came to an end on the Connecticut River. So now we're trying to pass river herring. And so here is a video showing that weir. It's plunging, it's not streaming. We have no submergence. And remember that picture of that roller and how the fish would orient the wrong way? Well, look what the fish are doing. They're coming up to that weir and they're turning right around, and they're actually diving down. And so this is just kind of a look at the fish behavior and how they interact in that regime. And the big reason why we really promote the more submergence, the better. Which brings us to our next fishway type, which is the vertical slot. And we have 3D printed fishways out back, so once there's a break, take a look. A vertical slot is a pool and weir variant. It's not necessarily passing flow over a weir, but what it does is it constricts the flow through these vertical slots. And those slots go all the way down to the floor of the fishway. If you see on the right, that's our counterpart, a NOAA engineer. He's a good 6 feet tall. You see how tall those weirs can be. So now we can operate under a really big head pond swing, has lots of submergence. The flow's in the range of an ice harbor. And so here's an example of a half vertical slot up in Maine. The picture on the right is if you drained all the water, hopped in and looked downstream, so the fish come through those slots. It has over 5 feet of submergence, a low EDF, and passes a whole lot of fish. And that includes juvenile eels, which is to me, a big highlight of vertical slot. So here I'm going to take you down in to look at that. And it's a little hard to see, but you can see the slot there. And there's a couple fish that come through right there. And you can see how easily they just swam through that. Remember the ice harbor, they were all disoriented, they were diving down. This type of fishway allows them to swim right through the vertical slot. So, a couple minutes I have remaining just to recap, the key elements of a successful fishway. And now, just to reiterate, I'm talking about internal efficiency, how well the fish can move through the fishway itself once they're already in. And that would be velocity. We need to avoid fatigue. The depth, that submergence depth is key, especially for low scenes. And EDF, avoiding turbulence. We want to provide a clear path for these fish. And really all three of these key elements are driven via the amount of flow in the fishway. So we may have a minute, 3 minutes. minutes. Do we have any quick questions before the next one?
Yeah, in that last video you showed of Enfield, it was quite a long slot. What's the variation in the velocities from the top to the bottom? Are they consistent, or are they going down to get to a better velocity?
That's a great question, and something I absolutely should have mentioned. That is the real highlight of vertical slot, in that if you got 6 feet of water in there, if you got 8 feet, 10 feet, the hydraulics really don't change, because the drop in water is up top. So as you go down, you know, it provides a nice path for the fish. Brett, where am I going here? Oh, here. Any other quick questions?
Are you going to pushing towards vertical slot then? I don't see them highly recommended often in the east, so is that kind of where you guys are heading right now?
There's a big push for that. To give you a recent example, Main Street on the Blackstone River in Rhode Island, initially that was going to be a denial. There's now consensus that a vertical slot should be put in. There's one going in up in Maine at the Lockwood Dam, a bypass fishway. But you know, this unfortunately the driver is cost. You know, we can't put these everywhere. But it's definitely something that, I mean, correct me if I'm wrong, we definitely are leaning towards.
I think it's fair to say that 2030, I mean, the history of fish passage in the Northeast is 20 years behind the West Coast. Basically, we took everything that the West Coast had learned from Pacific Salmonids, moved it out to the East Coast, and then learned, oh, a lot of this doesn't work. So in the past, those ice harbors were built. We never recommend something like that. Some of the large pool and weirs, I think it's a fair statement to answer Laura's question that in terms of pool type fishways, vertical slot is probably state of the art. But even within that, there's a couple dozen different ways it can be designed. So that's a fair statement, I think. Given what Brian said about the need for a low season submergence, depth of flow, that underscores my report.
Small scale and large scale vertical slot then too? I mean, would you still then create that kind of design at a smaller scale instead of a steep pass, let's say?
Yeah, I would avoid that. I'm curious what they say, but I would avoid that. Once you get below something that's a 6 foot square pool, I worry that a vertical slot wouldn't function as designed, because part of its function is to create a snaky path. It's not shown there, through the pool itself. Also, when you get in what's the one, Blackman Stream up on the Penobscot River watershed, where the vertical slot isn't very deep. So Scott asked the question about the depth, the velocity through that water column. Well, the velocity largely doesn't vary because the operative, to nerd out for a second, the operative cause of frictional loss is the sides, whereas a weir it's the crest. But once you get to a vertical slot that's only a few feet deep, I don't think it functions as a vertical slot. So smaller than 6 by 6 or depth less than 3 or 4 feet, I would stay away from vertical slot. At that point, you're really left with the backward shoot or something.
Okay, so we're still not thinking any kind of pre-manufactured vertical slot though, if we're looking at 6 by 6 still. We're talking concrete.
One, but
Okay.
I'd love to.
Okay.
And then I would add to that, if you are dealing with schooling fish like murky shad and river herring, we have some minimum widths that we want to work with. And the vertical slot, as you mentioned, needs to be scaled up or down. And so I don't think we're recommending anything lower than, or smaller or tighter than 16 inches. Is it?
18.
18 inches for a murky
The
shad.
slot width, right? That's
Okay,
a good
the slot
point.
width.
For the
Thank you.
opening. So that means that everything else will be a big fish weight. So if you're passing American shad, you are stuck with a vertical slot that is pretty significant amount of concrete and work. So they tend not to be cheap solution. So
That is a great point. The slot width drives the geometry of that whole system.
But that's if you have shad in your system. What if you're just looking at herring?
You'd still be looking at least a foot,
foot.
and I mean,
Foot.
you know,
Yeah.
it's still
Yeah,
pretty big.
Yeah, and then when you, it was like comparing like, well, with the Neo or Steve Bass and the costs.
Yeah, yeah.
If you were designing something for resident fish, brook trout or something like that, just if you weren't a teeny species, you're less worried about it. But with the schooling fish, it's not that they can't fit through the space, it's that they like to see their friends following them or leading them.
Good point.
All right, so I'm gonna move forward here. So the next topic is attraction. So we just talked about the hydraulics within a fishway and how best to pass fish. But you got to get the fish in the fishway first before they can pass, and that's not always a small task. And the key puzzle pieces to this is the quantity of flow that you're pushing out of your fishway, the velocity of that flow, so really the momentum of that water, and then I would almost highlight the puzzle piece location, because location is everything. You could have the right flow, the right velocity, but if it's on the wrong side of the stream, if it's positioned in a turbulent area, well, you're not going to be effective. So a lot of biologists in the room. I'm not sure I have to reiterate this one, but you know, the key to attraction is this inherent behavior of fish called rheotaxis. Positive rheotaxis, meaning they want to swim against the flow, and then negative rheotaxis for our downstream migrants, they're going with the flow. So sometimes attraction to a fishway entrance is obvious. On the upper left, that's a site that we constructed a couple years ago on Rhode Island, where we carved a channel in that stream bed specifically so that fish would be guided directly to the mouth of that fishway. That's kind of your idea. But it's a small dam, it's a small system. On the bottom right, now you're dealing with a major dam on a big main stem river with conditions that look like that. Where do you put your fishway? So the first puzzle piece being flow. So we need to push out the appropriate amount of water out of our fishway to create that hydraulic cue that will cause the fish to orient towards our fishway. And it needs to provide this cue under competing flows. And so, you know, you're going to have spill over your dam. You might have gates, you might have log sluices, you might, if you're at a hydro station, you have the turbine discharge. And so we need to produce a flow that the fish can just, you know, see among all the other flows that are going on. And so, just to recap on some of the fishways that I showed you, if we just put that amount of flow out into our tailwater to attract fish, we're talking, you know, steep pass 3 to 10 CFS. We might get up to 50 CFS with an ice harbor vertical slot, but is that enough water? And so here's some competing flow examples. On the upper left is a fishway on the Androscoggin River, and you can see it's a turbulent mess. The fishway entrance is in this corner over here. You don't see any signal, and what do you know? It doesn't do a great job at passing fish. Over here, again, you know, sometimes we're kind of stuck with the fishway entrance is actually right here. This is a spillway. This is a downstream sluice that's putting water into your tailwater. So if I was a fish, I wouldn't know where to go. Down here, sometimes you have a really wide tail race or in tailwater. In this case, the fishway is over on this bank. Well, do we know that the fish are properly guided over to that bank versus being all over this spillway or over here? And here's another one on the bottom right. This is a project in Rhode Island where there's a Daniil entrance right here, and again, you can see how turbulent it is, and there's no clear signal. So, how much water is enough? And this is where we engineers kind of have our hands tied behind our back, right? The best case scenario is we can use the full flow of the river. Best case scenario, the dam's not there. When dealing with hydro facilities, we may be able to get 5% of the station capacity, whatever that is, on the order of a couple hundred CFMs. But it's always it's always a balance of cost of if the dam owner is allowing you to use enough flow that you need to pass fish. And so a lot of times we supply additional water to the fishway. We call that attraction water. And that attraction water is fed into the fishway a few different ways, and we call these auxiliary flow systems, or AWSs. Up here, there's actually a couple. This is a site on the Merrimack River. This is a vertical slot. The entrance is here. The pool you see here, that's actually attraction water that dumps into that pool and then goes under the concrete wall and comes up through a floor to then go out the entrance. That's what we call a floor diffuser. So we're adding water via the floor. Over here on the right is a fishway in my hometown where it might be a little hard to see, but this is a Daniil. The water comes out this way, rounds the bend and out, so this is the entrance. Additional water is supplied to this volume right here, and then wraps around and goes through the wall. We call that a wall diffuser. So we're adding additional flow through the wall. Going back up here, we also supply additional water by an adjacent channel next to the entrance. And that creates what we call far field attraction. We're pushing out a lot of water so that fish can grab this signal and then come over, follow that seam into the fishway. And then something Brett has been working on the past few years with the Conti Lab is this new Palisade design where it's similar to passing flow along an adjacent channel, but actually has a guidance system so that the fish will be guided towards and into the fishway. So we can push out however much flow we're allowed to. And then we talk about velocity. And where the flow describes the quantity, the velocity is the momentum. You have this massive water, you want to push it out into your tailwater, and it's got to be a signal that the fish are going to respond to. And so, a long story short, our experience in the field, we always shoot for an entrance jet velocity of 4 to 6 feet per second. We find that with the fishways that we have, with the additional attraction water or not, 4 to 6 feet per second gets you a plume of water that will go into your tailwater on the order of, 20, 30 feet. So the velocity and the flow, that's our momentum, but we don't want to create a velocity barrier. So it's always a balance of trying to stay within that 4 to 6 feet per second and properly dissipating that energy within the fishway. But then this term submergence comes back to bite us, because you can have the right flow, you can have the right velocity, but submergence is key. Here's a site on the Merrimack. This is a fish lift. The entrance is down here. This red color is the shad densities. They did a telemetry study. And so what we found is the shad were right there. They were swimming right up to that entrance. Here's your entrance signal, nice and clear, perfect. Well, it doesn't pass shad. And that's because it doesn't have the proper level of submergence. Remember that 3 foot that I mentioned? They're not there. And so it's forcing the shad to swim up and find the entrance, and it does not work well. So submergence is a key. And now to location. Before location, how much time do I have? Perfect. I have another video for you. So here is a site in Rhode Island that has an entrance that unfortunately exceeds our 4 to 6 feet per second mark, and it doesn't meet the proper level of submergence for river herring. And you can see the behavior of the fish as they struggle to enter this fishway. There's a lot of fallback. They're diving down, trying to avoid this high velocity zone. You can see them just downstream of the stop log they have there. They're confused. They're not aligned well, and they look pretty stressed out. And I feel bad for the fish. Just downstream of this site is a project that we constructed just a few years ago, keeping that 4 to 6 feet per second in mind, keeping the streaming regime in mind, and keeping the submergence in mind. And you can see right here the conditions are very different. You see that entrance drop of about 4 to 6 inches. It's not plunging, it's streaming right along the top. And as we dive down in, you notice something. There's no fish. That's a good sign, because this was filmed on the same day as the other video that you just saw. So these fish are actively moving during that day. And so what you'll see here is a couple fish come into the camera, and they're in. That's why submergence is important for the low seas. Okay, now location. Location is everything. Now, generally, we want the fishway entrance, like this site, to be as far upstream to that barrier as we can. That's specifically important for river herring because, unfortunately, they can't read signs well, and they'll move upstream until they hit a barrier, and they will bump their heads against that barrier until nightfall, or until they're fatigued and they fall back. So put this entrance just a little ways down here, and you're not gonna see a lot of fish enter it. So that's one of the keys is we try to do that. And ideally, you want to situate it in a slow velocity, low turbulent zone. That's sometimes a battle, like this site. Again, this is the entrance over here.